Test. Okay, a very good afternoon, everyone. I hope that all of you are doing well. And also, I hope that you're keeping yourself safe and sound. Uh, you must have noticed that the university opens today on the 4th of October. However, it is not for students, but for staffs only. Moreover, the COVID-19 case numbers are going down, so that's quite a good news. So yesterday, I think it was 35 or something. So eventually it should come down, whereby we're going to 10, less than 10, 5, 4, 3, 2, 1, and waiting for the day where we have 0 new cases. Okay, so the time in which we start having continuous 0 cases, there's a time you may be allowed to enter universities. But so far for semester 2, 2021, you would be going through online courses only. Your final exams is something that is still of a doubt whether you will have a face-to-face final exam or an online based. So just to be on the safe side, it's good to be prepared. It's good for you to keep up with your studies, keep up with your revision, keep up with all the assessments. Now, for this week, we will be going over our lecture-based quiz. We'll be going our tutorial and lab in Thursday's class, okay? And also, I hope that you are working on your major project, and within a week or two, you should finish it up. Now, week 12, initially, I had thought of giving you a short test. Now, if you would have a look at your Moodle shell, under my assessments, you were supposed to have a short test last week. So I leave the open option for you. Leave the option open to you, whether you want to have a quiz in week 12 or week 13. So what do you reckon? Now, so base whatever you want to, when you want to have it, please leave a chat message as to whether you want to have your short test in week 12, which is next week, or in week 13. Completely up to you. Okay. So please quickly just drop me a chat message whether week 12 or week 13. Okay, thank you, Janesh. You had mentioned week 13. Okay, anyone else? Okay, another one says over there week 13. So we have 2 for week 13, 3 for week 13. Okay, so there's just 4 of you. So I'm guessing 3 of you have already said week 13. So let's have it in week 13. So next, this is week 11, by the way. Next week is week 12. The following week is week 13. Okay, your project, it will be due on the 31st of October. So if you look at on the 31st, this is week 11, week 12, week 13, week 14. Okay, week 14 Sunday, this is where your major project is due. Also, week 14 Sunday is the day where all your lecture-based quizzes are also due. Okay, once you miss on your lecture-based quizzes, it's a miss. Okay, so those of you who will be watching this video later onwards and you are not in the class, hear me out. With the lecture-based quiz, 31st October, 11:59 p.m. is the last time, even for the quiz that you will have in week 14. Okay, if you miss it, it's a miss. Okay, so you will lose. If you miss the final one, let's say, you will miss about 1.5% or something like that. So please ensure that you attempt all your lecture-based quizzes on time. Your project is due also on the 31st. Okay, now just in case, most likely sometimes in next week or after next week's tutorial class, I will be talking to you as to where you have progressed so far. You should be finishing it up very, very soon. Okay, so far I hope that all is well. If you have any questions or queries, I'll give you a minute or so to actually ask questions, and if there are any major issues, we can solve those issues. So any questions, any queries from anyone? No? Okay, if no questions or no queries, let's proceed with our lecture notes. Okay, now our lecture notes has a quite number of slides in it. Okay, so I will try to finish it up within 1 hour 15 minutes to 1 hour 30 minutes. Let's keep it to that time frame so that you do not get too monotonous. Now, today's lecture notes is about data design. That means what are some of the designing techniques that you could use to feed in data or to use data. Now, generally, when we talk about data design, we usually tend to talk about databases. Okay, why databases? Because database is the main component that keeps a good track of your data. Okay, so we'll be talking mostly about it. Now, in today's lecture, the key objectives are explain file-oriented systems and how they differ from database management systems. Explain data design terminology, including entities, fields, common fields, records, files, tables, and key fields. Describe data relationships, draw an entity relationship diagram, define cardinality, and use cardinality notation. Now, I will not pay too much attention on cardinality and use cardinality notation. Now, just a question to education students. Have you done CIN603? Education students, probably Monish or Musharat, you can answer this. Have you done CIN603 or is it part of your program? Any idea? No, right?
The CIN603.
CIN623, yes.
Yes, sir.
It's not part of your program, right? Is it part of your program or not part of your program?
We are doing that unit this semester.
You're doing it this semester?
Yes, sir.
Okay, so you're doing it this semester. Okay, so that is definitely part of your part of your program. So in that, you must have learned about ER diagrams, entity relationship diagrams.
Yes,
you
sir.
Must have learned about cardinality. You must have learned about cardinality notations, normalizations, and all those things. Okay. Now, so this is where I will not touch in too much deep into cardinality or cardinality notation or even normalization. Why? Because it's generally covered in CIN603, so you'll have it there. Or even for those students who have not done CIN603, I will not take you into that deep. Why? Because generally when you do normalization, when you do entity relationship diagrams, you need to work with databases. That means you need to create a database file. And from there, you have to manipulate data using certain ways. And you have to use cardinality relationships or notations, as we call it. And from that, you are able to work on normalization. 1F normalization, 2, 3, something like that. Okay, so I will not go too deep into cardinality notation. So we'll just go and quickly brush over ER diagrams. And we'll also look at them, explain the importance of codes and describe various coding schemes. We'll also go around explaining data warehousing and data mining. I think last week we did have a look at it, data warehouse and data mining. Data mining is a section of the warehouse. A warehouse is basically bulk of data. Differentiate between logical and physical storage and records. Explain data control measures. So when you talk about data control measures, you're generally looking at the security concerns or as to how you can maintain or control the flow of data in and out of the organization. Introduction begins with a review of data design concepts and terminology, then discusses file-based systems and database systems, including web-based databases. Concludes with a discussion of data storage and access, including strategic tools such as data warehousing and data mining, physical design issues, logical and physical records, data storage formats, and data controls. Now, things that I would like to pick up from here is, first, you have a file-based system, you have database systems. Okay, now database systems or file-based systems can be web-based. That means generally this entire database platform or the data manipulating platform is on a website. Okay, for example, Moodle. Now Moodle also has a database. Okay, so what you're seeing is the client-based interface. So it has a database which basically keeps track of each every data in a specific web-based file. All right, so web-based database, very good example is Moodle. And what this particular slide is further explaining is we'll be looking at some of the tools that is used to make decisions in regards to databases, strategic tools. Data structures. Each file or table contains data about people, places, things, or events that interact with the information system. So there are two types of systems. Okay, you have a file-oriented system and a data management system. Now, a file-oriented system could be something as you keeping a track of data in Microsoft Excel, or you keeping a track of data in Microsoft Word. It's a file-based system. With a DBMS, you are keeping track of data in Microsoft Access. Now, why I'm giving examples in terms of Microsoft applications, because this is something that you've already used. Microsoft Access, you should be well familiar. You've learned it in your very first semester, CIN603. Okay, so with databases, you have dealt with Microsoft Access. There are many other different types of databases. For example, Oracle, you have MySQL and so forth. But the common one that you all should be familiar with is Microsoft Access, and it's also easy to understand. Now, with databases, what do we keep track of? We keep track of data that are produced in an organization. What kind of data? Data that relates to people, data that may relate to places, data that may relate to certain events or processes. Example, you making payments or receiving payments, and so forth. Data design concepts. Overview of file processing. File processing can be efficient and cost-effective in certain situations. Potential problems: data redundancy, data integrity, rigid data structure. Now, what happens is when you are using a database management system, like what happens, it becomes very cost-effective in a lot of situations. Why cost-effective? It becomes very easy to maintain. It becomes very easy to update data. However, there are potential problems when you use file processing systems. Example, you have data redundancy, repetition of data, data integrity. When we talk about data integrity, that means the old data and the new data, they may mixed up in one way or the other, and you're not able to easily identify which one is the latest data and which one is the old data. So data integrity assists in doing so. However, with file processing systems, you don't have much data integrity. Now, and you have a rigid data structure. When you talk about a rigid data structure, meaning you cannot go around expanding the tables, or it makes it very difficult for you to expand tables. All right. Now, if we try to compare it with DBMS, database management systems, it's easy for you to go around editing things. It's easy for you to go around, inserting new rows or a new field, and you can manipulate data in one way or the other. So with file processing systems, it does not allow you to do so. Now, overview of file processing, various types of files. You have master file, you have table file, you have transaction file, you have work file, security file, and history file. So these are the different types of files that come under the file processing systems. Now, over here, I wouldn't suggest for you to know the definition of all those. Just know that there are these kind of file systems. So you have master, you have table, transaction, work, security, and history. Now, evolution from file systems to database systems. A database management system, also called as DBMS, is a collection of tools, features, and interfaces that enables user to add, update, manage, access, and analyze the contents of a database. Now, it is important for you to know what a database management system is, okay? And for you to know the definition as well. So you can mark it down somewhere. So with the DBMS, it gives you a collection of tools. Now remember Microsoft Access, okay? You have set of tools on the ribbon, okay? On the tabs, on the groups, okay? It has features, it has interfaces that allow you to add, update, manage, access, and analyze the contents of a data. Now, adding is good. You know how to add, you know how to update, you know how to manage, you also know how to access it. Now, accessing means you to control the access. So you can always set up a password, okay? And analyzing. Now, how do you analyze the contents of a database? You can make charts. So to the use of charts, you can analyze and evaluate and make conclusive decisions. The main advantage of database management system is that it offers timely, interactive, and flexible data access. Okay, so these are the three main advantages. Timely is you can access it as you want to. Okay, interactive, that means you can always have it interactive. So how do you make it interactive? Remember, I don't know if you still remember or not, in CIN 501, I think most of you did CIN 501 with me. So when we were making databases, the reports, then we made buttons on the sides. Okay, add button, delete button, print button, close, next, previous, and so forth. Interactivity. Okay, rather than you entering those manually or inserting codes, so we basically mix up with some graphical user interface, had some buttons in place. Okay, click on it, and we were able to perform certain commands like editing, updating, deleting, and so forth. Now, flexible data access, how is it flexible? The word flexibility here, it means that it gives you certain liberty. It gives you certain freedom, okay? Freedom to add or delete, freedom to go around modifying things. So once you made a report, you feel that the report is too small, you can always go and do a design, go into design mode and update it and extend it to the size that you would like to. So flexible approach and flexible data access. The evolution from file systems to database systems. Some advantages include scalability. Now, databases, definitely they are scalable. Scalable meaning that they can actually entertain your ongoing demands, better support for client or server systems, economy of scale. Now, what is economy of scale? The economy of scale, if you have done economics in high school, this is the common one. This is one of the common things that you must have learned in Form 6 or Form 7 economics, is that when you produce a large level of production or increased level of production of a specific item, your overall cost decreases, therefore increases your savings and revenue. Let me repeat that. Economy of scale, when you produce an increased level of production, that means the more of items that you produce, your overall cost decreases and the revenue rates go up. That's economy of scale. So database allow you to do so. You have flexible data sharing. Now, flexible data sharing, how does Microsoft Access allow you to have flexible data sharing? You can always share the files over our network. Okay, how do you do that? Go to the file section, and then you have a sharing option, and you can share it with everyone or share with certain individual via the use of their emails. Okay, enterprise-wide application, database administrator, and then stronger standards. So these are some of the advantages of database systems. Interfaces for users, database administrators, and related systems. So if you look at on the left-hand side, you have something. Now, where do you use this? For what feature do you often use this? Anyone has any idea? When do you go around using your Microsoft Access and have this kind of interface coming in? Let me see how many of you can recall it. Anyone? When do you use this? Or when do you have this interface coming in? Are you making reports, queries, forms, tables? What?
Queries.
Queries. Yes, thank you. So when you are creating a query, now with a query, you can create extensive reports which could be analyzed. Okay. So when you are creating a query, you have this interface showing in. Now, users, you have query language, you have query by example, QBE. Now, this is a type of a language, okay? And then you have SQL, structured query language. So those of you who have done CIN603, you have learned how to use SQL, okay? And then database administrators are DBA, or database administrator, is responsible for database management system management and support. So the database administrator, okay, they have a key role to ensure that the data is well maintained and all adequate support is effectively provided to them. Interfaces for users, database administrators, and related systems. Related information systems. Our database management system can support several related information systems that provide input to and require specific data from the data management system. Okay, no human intervention is required for two-way communication. This is pretty plain and simple. Okay, database manipulation language. A database manipulation language, DML, controls database operations, including storing, retrieving, updating, and deleting data. Now, a DML can be used to perform certain functions. Okay, now you can either use to the use of coding, or you can use it through the use of graphical user interface. Have a look at this. Now, if you look at the first one, this set of options, this all, now this is where you are using graphical user interface. However, you can have the same thing done to the use of code. Okay, so you can insert this confusing set of code. By the way, it's not confusing. Those are the if there's someone who knows Visual Basic .NET, they could easily go around typing this and they would be able to get the same result as what you have achieved from using the graphical user interface. Okay, so that's where DML comes in. Schema, in general terms, schema gives an overview of your databases. It gives all your fields, your tables, your relationships, and a good sort of description about them. Okay, the complete definition of a database, including description of all the fields, okay, tables and relationships, is called a schema. You can also define one or more sub-schemas. That means a sub-schema is a schema which is defined underneath another schema. It's called a sub-schema. Like you have a topic, let's say the topic is food, so the subtopic is energy giving foods. Okay, so same thing here, schema, sub-schemas. Physical data repository. The data dictionary is transformed into a physical data repository. So you have two types of data repositories. First one that you have is a logical. Logical is something that is drawn off, logical is something that is put on paper and designed as such. Now, logical databases can also be done through the use of a ER diagram and so forth, or even a data flow diagram. So when you have something in form of a logical, okay, like I mentioned, a data flow diagram, we also have data dictionary as well, which could be described as a logical design. So the logical design is generally and later onwards transformed into a physical data repository. So when you are doing a physical data repository, you are actually creating the database in a certain database application. The physical repository might be centralized or distributed at several locations. Centralized, single location. Distributed in more than one different locations. Okay. For example, Moodle. Okay, Moodle has a database which is hooked up to a Moodle server. So the Moodle server is based in Nasinu campus. All right. So once someone would go around updating something from Nasinu campus, so they are using the central system. However, let's say I'm here in Nandi, and then I am trying to ensure that the Moodle page is updated, and I update something on Moodle. So what I'm doing is I'm using the distributed system. The distributed systems generally work with networked, okay, networked systems or network computerized system. Central is just one, single. Web-based database design. So web-based database design, it is same as a normal database, except that it is on a browser. Okay, so you can access to it to the use of a browser. Now, if you have used MySQL, okay, you'll notice is that when you're working with a database, you have to go around doing everything on a browser. Okay, so that's a good example there. So characteristics of web-based design: global access. The internet enables worldwide access using existing infrastructure and standard telecommunications protocol. Now, what it means over here is that it allows you, when you have a web-based design, no wonder or anywhere in the world you are, you will be able to access that particular database. Ease of use. Web browsers provide similar interface that is user-friendly and easily learned. Okay, so web browser, anyone can use web browsers these days. Okay, if anyone can go around using Facebook and make their way through it, why not use with a database? Okay, if it has familiar interfaces, definitely you should be able to do that. Now, databases, they support, or web-based databases, they support multiple platforms. Okay, web-based design is not dependent on a specific combination of hardware or software. All that is required is a browser and an internet connection. When you talk about multiple platforms, there are many different platforms in which your computer can work in. Your computer may have a Apple Macintosh platform, it can have a Windows platform, it can have a Linux platform, it can have a Unix platform. So despite all these platforms, your web-based interface or your web-based database design, it can work despite whatever platform you have, because you need a web browser and internet connection to actually use it. Cost effectiveness. Initial investment is relatively low because the internet serves as a communication network. Users require only a browser, and a web-based system do not require powerful workstations. Flexibility is high because numerous outsourcing options exist for development, hosting, maintenance, and system support. Now, again, now your web-based databases, they are cost effective, meaning that, for you to actually have it set up, okay, you would only require a browser, and a web-based system does not require powerful workstations. Okay, however, if you have something like which is not web-based, for example, you have to purchase a large software, for example, something related to Oracle, let's say Oracle database. If you have to go around purchasing MySQL Workbench is an example. So if you do that, what happens is generally your computer would have to meet certain types of specifications, for example, certain RAM, certain memory, certain processor speed. However, if it's web-based, you don't require much memory, or you do not require much space or much processing capabilities to use a website, do you? No, you don't. So therefore, cost effective. Security issues. Security is a universal issue, but internet connectivity raises special concerns. These can be addressed with a combination of good design software that can protect the system and detect intrusion, stringent rules for passwords and user identification, and vigilant users and managers. Yes, with every web-based system, security is a major concern. Why? Because you have so many types of perpetrators who could actually go around and misuse the system. But to detect it or to ensure that your database is safe, you can always use some intrusion detection system or some stringent procedures to go around controlling your username and passwords. Adaptability issues. The internet offers many advantages in terms of access, connectivity, and flexibility. Migrating a traditional database design to the web, however, can require design modification and additional software, and in some cases have related expenses. Okay, so what you're talking about is adaptability issues, how easy it is for people and how easy it is for the system or the computers in your organization to adapt to web-based. Always, whenever you are creating a new system, a concern rises whether the existing people could use the system or not. Now, it's not impossible. Yes, people can go on and using it, provided that they are given some sort of training. Okay, if you would conduct training, for example, if I would ask you, all of a sudden, all right, I give you access to Moodle, can you go on updating the Moodle shell for a particular course? Will you be able to do so? Probably you will make your way out, so in one way or the other, but you will find it a bit difficult, or it may take you a lot of time to actually get used to it. So if instead of that, somebody provides you with a basic training of all the tasks that you need to do, it will become very, very easy. So likewise here, adaptability issues. Now, with web-based comes in some certain terminologies, and I'm thinking all of you are well aware of it. Web browser, you know what a web browser is. For example, Google Chrome, Internet Explorer, Mozilla Firefox, Mozilla Firefox. So these are examples of some web browsers. Web page. So website and web page, they are two different things. With a web page, it is a single page on the browser. However, with a website, you combine many pages, you link them up, it becomes a website. HTML, hypertext markup language. This is the very basic language in which it could be used to create websites. Tags. Now, tags in this case is generally related to HTML. HTML often have a set of tags, opening and closing tags, in which a website or a web page is developed. Web server. A web server is basically a computing platform. Either it could be hired on lease or you could own it. And the major purpose of a web server is to store files and give access to its users. Website, we've already discussed about it, combination of web pages. Internet terminology is continued. You have intranet. So internet is a form of a network that is only used by people within the organization. Extranet is also a network, but here, instead of using it only within, it could be used within and outside the organization as well. A very good example of intranet is okay, let me put it like this. The student management system that we have here in the university, it could only be used within the organization. Okay, so nobody outside could go around using it. When we say student management system, Moodle is not a student management system, it's a learning management system. Student management system is whereby we have all your records in them. Okay, now it could be only used within the organization. Extranet example could be Moodle. It could be used within and outside the organization. Protocols, when you talk about protocols, it is a set of rules in which data is supposed to be transmitted. So when you talk about data transmission, it is talking about sending and receiving of data. So protocols are the rules that enables communication or the transmission of data. Web-centric is something that is centered around the web technology. Clients. Clients are those computers that request for information. Servers, these are those computers that corresponds to those requests that the clients have requested. All right, so these are some of the basic terminologies. I would suggest from here, know what an intranet and an extranet is, know what is a client, what is a server. Let me repeat that. Do know what an intranet and extranet is and know the difference between client and server. Web browser, I think you all know what a web browser is. If you don't, please note it down somewhere and learn what that is. Website, web page, I think you should be okay with that. Slide number 17. Web-based database design. Connecting a database to the web. Database must be connected to the internet or intranet. Now, internet is basically a combination of networks. So we call them as internetwork. Internetwork is a long form for the word internet. Okay, internetwork, that means many types of networks or many networks joined together. It forms internetwork. Internet is basically a network only within the organization. So our internet can be counted as a local internet, okay, or a local network, whereas a internet, on the other hand, could be counted as something that is within and outside, therefore extranet. Middleware are those kind of softwares that allows two different platforms to correlate to one another. And an example is given, Adobe Cloud, Adobe Cold Fusion. Don't worry about that. Okay. Data security. Well-designed systems provide security at 3 levels: the database itself, the web server, and the telecommunication links that connect the components of the system. Now, this is very important to understand this. So when you are just setting up a database, so you need to provide security to the database, you need to provide security where the database is stored. So the database will be stored in a web server, okay? And you also need to provide security to the telecommunication links. What are telecommunication links? The network itself. So let's say if I am based in FNU Natambua campus, so we make a database. So first of all, we need to provide security to the database, probably appropriate username and password, appropriate access levels, okay? So then security is provided for it. Then the database, I would place it into a web server. So when I place it into a web server, so the web server should also have security such as antivirus programs, intrusion detection systems, and also good strong username and password or authentication in that case. So once that is done, so the telecommunication links also need to be given security. So what will be the telecommunication link? The entire networking within the Tumbo campus. Okay, so how security is provided to them, adequate username and password again. It also needs to have an intrusion detection system. The network administrator may go around using some network monitoring kind of applications to see if there's any unusual activities and so forth. Okay, so security to be provided at all of those three levels. Now, database design terminology. So definitions, entity. So what is an entity in database? An entity in a database, it can be almost anything. It can be a single person, it can be a single thing, single place, or single object. So that entire thing is called an entity. So an entity has a table or a file. Let me give you an example. So if I'm creating a database and if I would name the database as CIN603 students, so the entity is CIN603 students. So inside the database, I will have records such as a student table. I'll have unit table or course table. I could have program table and grade table. So those would be the file. Now inside the file, I would have fields. Look at the diagrams on the right hand side. Student number is a field. Student name is a field. Total credits is also a field. GPA is also a field. Advisor number is also a field. Now inside the field, you have records. Okay, record is basically the entire of these details. Okay, so a record for 1035 is 1035. Linda Mary Anderson 14 3.214 49. It's a single record. Another record is 3397, same car, 9349, another set of record. Now within a record, for example, if I would say same car, now so same car is a tuple, okay? Single element within a record is called a tuple. Let me repeat that entity, the entire name of the database. So in the database, you have tables. So the tables are called as file. Inside a table, you have fields. Fields are generally, let's say, the headings that we give for each and every column. Okay, student number, student name, total credit, GPA, advisor name, social security number, advisor name, and so forth. So these are called fields. So within a table, you have fields and then you have record. A record is a complete set of data for an individual person. So over here, the person is Linda Mary Anderson. So these are all the records for her. Okay, we have CHM112, the course ID. So the entire record of the course ID is CHM112, General Chemistry 1. Number of credits is 5. And a single element within a record is called a tuple. For example, 5 is a tuple. CHM112 is also called a tuple. General Chemistry 1 is a tuple. So separately, each of them are called as a tuple. Able to get me, people? It's not confusing. You've worked on this before. You've worked on Microsoft Access right when you had begun with your semester. Okay, semester 1. So this is your second year, if I'm not wrong. So semester 1, 2019, now 2020, you have worked on this. Okay. Now, key fields. There are generally 3 types of keys. We have a primary key, So in this case, your primary key is student number. So the primary key is the unique identifier within a record. Okay, so 1035, 23, 49. Okay, ENG 101, something that uniquely identifies your record. Foreign key. Foreign key is when your primary key appears in another table. For example, let's go and hunt for this. I don't think we have it in here, do we? No, we don't. So let's say if 1035 would have been somewhere over here under student name. Yeah, under student name somewhere over here. So we would have said that 1035 is a foreign key. When the primary key of one table exists in another table, it's called a foreign key. Now, secondary key, I'm not so sure whether you know what a secondary key is or not. Secondary key are those keys that has not been selected to be the primary key. So these are secondary keys: student name, total credits, GPA, and advisor number. Okay, so these are what are secondary keys. Now have a look at this. So you have advisor number as 23. So this 23 appears in another table. So what kind of key is that? Primary key, foreign key, or secondary key?
Foreign key.
Foreign key, whereby the primary key goes into another table. So that's a foreign key. 23 here in this table is a primary key, over there is a foreign key. So in this case, social security number and advisor name are secondary keys. All right, people? Now, referential integrity. Validity checks can help avoid data input errors. In a relational database, referential integrity means that a foreign key value cannot be entered in one table unless it matches an existing primary key in another table. Okay, now what happens in referential integrity? It allows you to build correct relationships. For instance, if you want to have a table, now let's go back to this one. Okay, so if you want to have this done, and let's say you put in this table, and advisory number you say is 23, okay, but 23 is missing from here. If it's missing from your advisor table, you will not be able to build your referential integrity. So how do you build referential integrity? See the checkbox when we actually make relationships. Okay, so if you will not have 23 existing in the primary table, okay, but it appears on another table, so what happens is that your referential integrity cannot be enforced in that case in time. So you need to ensure that you need to fill in the values very, very accurately. Now, what is the purpose of referential integrity? It's just a way of ensuring that nothing is incorrect in your database. If you have an error when you're trying to enforce referential integrity, that means something has gone wrong somewhere and you have to go around edifying or modifying it. Drawing an ERD. Okay, so we'll quickly go over this. If you're doing CIN603, 623 rather, you know how to make an entity relationship diagram. First step is to list down the entities that you identified during the fact finding process and to consider the nature of the relationships that link them together. Popular method is to represent entities as rectangle and relationships as diamond shapes. So entities, okay, so you have a doctor, you have a patient, okay, and the relationship between the two is that the doctor treats a patient or a patient is treated by a doctor, okay, and you generally go around giving them some form of a explanation as to how it works. So the types of relationships that you have generally in databases, you have one-to-one, you have one-to-many, you can have many-to-many, okay? One-to-one, 1:m is one-to-many, and then M to N is many-to-many relationship. We don't have M. Now, many-to-many relationship is presented by M:(n) and not M. This is correct. This is definitely correct. Is M:(n), many-to-many. And this is how you would go around representing it, okay? One and one only form of relationship, one-to-many, zero or many, and zero or one. Okay, I will leave this to you, that you are already learning this in CIN603, how to build around the relationship. And since we're not going to draw ERD diagrams or ERD is in CIN603, so we'll just let it be as it is in this slide. Overview of codes. So using codes during data design. So because codes often are used to represent data, you encounter them consistently in your everyday life. They save storage space and costs, reduce data transmission time, and decrease data entry time, can reduce data input errors. So the types of the codes that you generally have when you are designing your data is you have sequence code, you have block sequence code, you have alphabetic codes, significant digital codes, you have derivation codes, you have cipher codes, and action codes. Okay, we will not be going in broadly into this. Okay, so those I would say just to note some of the types of the codes. For example, sequence codes, they go one after the other. Okay, block sequence codes and so forth. Cipher codes, if you are doing a CSIS program, you'll learn about cipher codes in CSC726, and you'll actually go on creating cipher and deciphering codes, based algorithms. Okay, so yeah, so just know some of the types of the codes. Okay, developing a code. So how do you go around developing a code? First of all, keep codes concise. Concise means simple and clear. Allow for expansion. Keep codes stable. Make codes unique. Use sortable codes. Avoid confusing codes. Make codes meaningful. Use a code for a single purpose. Keep codes consistent. Okay, you must have noticed that I'm not explaining a lot on these, so that should indicate that these are not so important. Okay, now database design, step one at a time. Create an initial ERD. Next, create an ERD. Review all the data elements. Review the designs for all tables. Double check all data dictionary entries. After creating your final ERD and normalized table designs, you can transform them into a database. So what's happening here is basically, this is where it describes and gives you the steps in which how you should go around creating a database. Now, generally, if you looked at in CIN501, when we started creating a database, we drew up a schema first, a table listing down all the fields and the related description. So the description would be is, for example, something like the student ID. This represents student's ID, data type, for example, automatic, auto, something like that. Okay, and then student name, names of all the students, data type, short text or long text, something as such. Okay, now in actual terms, the same procedure is also followed. So you make a schema. So from the schema, you actually get the name, the description, and the data type. After you had it done, then using the field names in the schema, you'll go and start creating an entity relationship diagram. So once your entity relationship diagram is drawn, you cross-check everything, you review the designs, and then you will actually go and start making data dictionary entries. Okay, so data dictionary entries and schema, you can put it the same thing. So if you are drawing schema, sometimes people do not have data dictionary. So from the schema, they go to ERD, and from the ERD, then you actually start creating the database. Okay, so that is a standard procedure in industry, and this is how people go around doing it. Now, also note from here is your schema in ERD plays a major role. Even though those are, it may seem like unnecessary to draw those diagrams, to draw those tables. However, if you draw them correctly, if you draw them concisely and precisely, what would happen is that you will not have any errors in your database, and the entire workflow becomes very, very easy and simple. Now, if I would ask you to go and make a database and you're not given a schema, you're not given a ERD or a entity relationship diagram, it becomes very difficult. Okay, so please do know this, the major purpose and what purpose they play in databases. A real world database example. Imagine a company that provides on-site service for electronic equipment, including parts and labor. Okay, so you have a on-site service for electronic equipment. So this is what the company does. So you have labor, a table for labor. You have a table for parts, table for service parts detail, service labor detail. You have service call, customer, and technician. So what I'm guessing here is everything depends on service call, okay, and linked up to customer, linked up to technician, and then your service labor detail and all the labors, and your service part details and all the parts. Okay, so when you look at the relationship structure of this, so you should be able to actually think, okay, this is how the database would be. Working with relational database. To understand the power and flexibility of a relational database, try the following exercise. Suppose you work in IT and sales team needs answers to 3 specific questions. The data might be stored physically in 7 tables. So generally what I want to ensure is you know what is a relational database. So a relational database is something that you're doing in Microsoft Access. Okay, so that is a database with a tabular structure. Okay, relational database. Data storage and access. Data storage and access involve strategic business tools. So when you talk about strategic business tools, you're talking about tools that actually provide or fulfill your long-term goals. Strategic tools for data storage and access include data warehouse. So data warehouse is basically a platform that stores a very, very large amount of data. So when you talk about large amount of data, you're not talking about data bytes, you're talking about petabytes and quaterbytes. Okay, that much amount of data. Data mart is basically one of the sections of a database. Now have a look at this. So you have data warehouse. Let's say in your data warehouse, you have data related to marketing, data related to sales, data related to customers, data related to creditors, debtors, and so forth. So detail just on marketing, or the data just on marketing can be pulled out into a section. So that section on marketing data may be called as data mart. Okay, so you have another set of data on debtors. So database on debtors would be called data mart. When you combine all those together, the different types of data on marketing, types of data on debtors, creditors, sales, customers, and so forth, they build up a data warehouse. Separate section of data, data mart. Then comes in data mining. Data mining is a concept of a broad spectrum. In the other words, what it means is basically is it deals with a large amount of data. So remember, you have data mart, smaller version, data warehouse, bigger version of data, and data mining is a concept or set of algorithms that is used to study, analyze, evaluate data so that you derive some sort of knowledge from there. For instance, I have a large set of data for CIN603 for the past 10 years of student results. So based on that, I can apply a set of algorithm and would say, okay, so based on this algorithm, the algorithm has analyzed, evaluated, and made a conclusion that students who do not perform well by mid-semester, they generally end up failing the course. So that's a knowledge that I've derived. So data mining allows me to do that. So it's just a set of techniques, set of algorithms, which is performed on a large amount of data, and it allows you to get a knowledge. Knowledge is something new. Okay, so there you go. Logical and physical storage. Now, logical, you have characters, data element or data item, logical record. Logical is something that is on paper, okay, that is on software. Physical storage, physical record of blocks, buffer, blocking factor. The main difference between the two is with logical, you plan something out. With a physical, you put your plan into action. Data coding and storage. So you have binary digits, you have bit, byte, Extended binary coded digital information exchange, that's EBCDIC, and ASCII, Australian American Standard Coding for Information Interchange, and binary and unit code. Don't worry about this, okay? Data coding and storage, storing dates. Now, Y2K issue. Are you aware of what Y2K issue is? Or what is a Y2K virus? Anyone? No? Okay, now let me explain it to you. When devices were first developed, let's say developed in 1980s or 1970s, okay? Now, many of those devices lasted for decades. Okay, for example, if you have a watch you bought in late 1980s, okay, and then you've been using it for quite a number of years, you change the battery, still working. So what happened with Y2K? Y means year, okay, 2K means 2000, okay, so year 2000. So there were many devices which had worked on dates, mobile phones, your watches. Now some watches, digital watches, they actually have year displayed on them as well. You have many devices like television, sometimes they display time. You have cameras and so forth. So what happened was when when programmers actually had designed those devices back then, they never considered into their mind that, you know, oh, let me put it like this. So when they had designed the dates, so the dates was one, it was one, and then 9 and the value, or 1 9 was one was stagnant. Okay, that means one was a permanent, and the other values could change, the other three values. So 1999. So that formed 1999. So 1998, 1972, 1972. Some or the other, these people who had first initially designed the program, they didn't realize that they would surpass the year 1999 and come to 2000. So what happened after 31st of December 1999, when all the dates were supposed, or all the devices were supposed to change their dates to 2000, instead of changing it to 2000, it changed to 1000. Why? Because one was the stagnant value, the fixed value, and the other values changes, okay, or the other value changed. So one was still 999. So as soon as it reached year 2000, all the devices, instead of changing it to 2000, it's changed to 1000. Now just imagine, try doing this. If you have a computer or a laptop at home, try changing the year from year 2021, just change it to year 2005. What will happen? The internet won't work. Why? Because it'll cause a clash with the security certificates. It'll cause a clash with your antivirus programs and so forth. So you will not be able to use the internet in any particular way. And also, please do note that some of the devices, they are basically very much dependent on time. Okay, for example, global positioning systems, the satellite connections, okay, they are dependent on time. So with Y2K, the issue was, so instead of changing it to the year 2000, it went around changing it to year 1000. And there were so many devices in the entire world which stopped working, especially our computers. Now, our computers, you may think, okay, your computer didn't work. Simple thing, people won't be able to use the internet for a day. No, it's not that. Now, when we say computers, we also look at servers. We also look at websites. So that in the servers, you have website data. So when the server date changed to a backdated, a very, very old, probably 1000 year back, the entire World Wide Web just collapsed. So that caused a very big issue. So that's why when you are storing your dates, you need to ensure that you are doing it very, very correctly. Okay. Now, most date formats are now based on a model established by International Organization for Standardization, also called as ISO. Now, what ISO does, it is an international body whereby the general standard is in place and implemented by this organization. Is not only it works in the ICT arena, it works, or ISO does a lot of work in the other fields as well. Now, the common one you must have heard about, the Fiji gas advertisements or the blue gas advertisements that we have in radios and TVs. They would say ISO 2009 certified, something like that. Okay, so that's where ISO is, and then absolute date. Now, data control. So when you're controlling your data, you need to ensure that you're using proper use of user ID, the user password. Password, that means you try to have a password that is difficult to be guessed out. Now, some people have a habit of putting down 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Now, there is one of the most common type of password that so many people had worked on in so many years, and it is easily guessed. So avoid that. Try to mix your passwords with a combination of numbers, letters, symbols, and uppercase and lowercase characters. Permissions. So when we talk about permissions, it's about you giving certain level of access and a certain level of rights to the people who are going to use your databases. So permissions could be set based on your database administrator has a certain level of permission. Your manager may have a certain level of permission. Your user, a plain daily user, may have the least amount of permission to do certain things. Okay, most likely there will be some people who just be reading the data, so they won't be allowed to modify or edit anything. Encryption, it is basically the use of certain algorithms or certain ciphertext to go and control your data. Backup, creating an additional copy to ensure it could be used when you go through a data loss. And backup can be used for recoveries as well. So that comes with our next point, recovery procedures. And then audit log files. What is the purpose for auditing log files? When we say we audit something, that means you go and cross-check. So when you do an audit log file, audit of log files, so what you do is you go and analyze the trend and see if there are any unusual activities. Unusual activities, that means there's a sudden surge. Let's say there's a sudden surge in your data. That means data has been used or transmitted at a very high rate all of a sudden. You may signify that something is wrong. Let's say on a normal day basis, the total amount of data that was used between the server and the database was, let's say, about a total of, let's say, about 100 MB per day. Now, all of a sudden, it has gone to 2 TB, from 100 MB to 2 TB. Now, that is a big concern. Why? Because it could be a possible virus. Now, what do you call that virus which causes a large surge of data? Let me see who can answer this. What do you call that virus which causes a large surge of data from the system? Anyone? What is the name of that virus? No one knows? It's called denial of service. So when you have DOS type of virus, denial of service, what it does, it causes a sudden surge or floods the computer with so many data requests that eventually the system crashes. So with audit files, you should be able to do that. Now, audit fields are just examples of whereby it allows a user to enter correct type of data. For instance, if the field is date of birth and you're writing your name in there, so what happens? It gives you an error stating that you need to enter date of birth correctly. Okay, and sometimes some fields will be labeled as compulsory field with the use of a red asterisk. So that is on audit fields. Chapter summary: files and tables contain data about people, places, things, or events that affect the information system. Database management system designs are more powerful and flexible than traditional file-oriented systems. Why and how? We've just looked at the advantages of DBMS. An entity relationship diagram, or ERD, is a graphic representation of all system entities and the relationship among them. So using an ERD, you should be able to properly define and draw up your databases. A code is a set of letters or numbers used to represent data in a system. The most common database models are relational and object-oriented. So object-oriented are those type of databases that could be entered without the use of any without the use of any codes. Object-oriented, that means you're using the interface to do so. Relational database, you can actually go and type things out. Logical storage is information seen through a user's eyes, regardless of how or where the information actually is stored, organized, or stored. Physical storage is hardware related and involves reading and writing blocks of binary data to physical media. So logical, it is just the purpose for planning. Physical is putting the plan into action. Files and database control measures include limiting access to data, data encryption, backup or recovery procedures, audit trail files, and internal audit fields, something that we've just talked about in the very last slide. So these are our contents for today's lecture. Now, is there any questions or any queries from anyone? Any questions, any queries from anyone? Now, I don't think overall the notes is too difficult to understand. Okay, it's about plain databases. Pick up the key terms, DBMS, okay, some ways in which you can protect advantages, disadvantages of database management systems. Relational database, do know what that is, know the difference between logical and physical designs, do know about Y2K issues, okay, and those would be some of the very important things from this sets or this week's lecture slide. Now, also note, just before most of you have joined us in, we have talked about your short test. I took a quick poll right at the very beginning of the class as to when do you want to have the short test. It was supposed to be held in week 10. That was last week, but most of you have mentioned that you want to have it in week 13. So we will have the short test and online quiz, 10% contribution towards your coursework on the 13th week. Your major project is due on the 31st of October, not too many days from now. Okay, you have close to about 20 to 25 days. Okay, so please ensure that you get it done as soon as possible. Okay, try to get it done within the next 2 weeks time. Moreover, your lecture-based quiz is also due in week 14 on the 31st of October, 11:59 p.m. Please note that no extensions will be given for your lecture-based quiz. If you miss it, it's a miss. Okay, because I feel that I've given you a lot of time. Am I right? Okay, now week 1, we started somewhere back in July, mid of July. Okay, it's due in 31st of October. If you're not able to complete it within the 3.5 to 4 months time frame, so I'm sorry, I won't be able to give you some more time to finish it up. Okay, so please ensure, start using your time very, very well. Okay, the next few set of weeks, this is week 11, we have 4 more weeks to go. Okay, 12, 13, 14, 15. So the next 3 to 4 weeks are very crucial. So please ensure to use your time very, very well. Okay, everyone? All right. So this is where we'll knock off the class for today. I like to keep it short, the classes. I think if it's short, it gives you time to go around and make short notes and do some additional work. And also it becomes less monotonous. It's not face-to-face, it's generally over an online mode whereby all you do is you are able to see the slide and hear me speak. So if we keep it short, I think it's more preferable from my end and also from your end as well. Somebody just popped up a question. Yes, Musharat.
Sir,
Yes.
if the class is over, about the major project,
Yes.
the second part of it says data collection. What does it require us to do when it says, what do we have to do in the data collection?
Okay, can I just quickly open it up? The question, I can. Okay, is this what you're asking? Here.
Yes.
Okay, now what you have to do over here is, okay, you have to think about some data collecting techniques. I think somewhere around week 4 or week 5 lecture, we have talked about some of the data collection techniques or methods. For example, if I have to give you an example, questionnaire is one of it. Okay, So in it, you have to basically use, now there are a lot of methods. There's close to about 10 or 11. Choose one or two and see which one gives you a best matching related to the case study in the scenario given, and also to the new website that you're going to make. For instance, when you are going to create a website for them, obviously you will need to go and do some form of research as to which website would look good. Now, what generally people do when they are creating websites is, for example, if somebody hires me to create a website and they say they want a website based on restaurants. So what I will do is I'll start doing some research work and see what are some of the trending restaurant-based websites. So my data collection method here would be research work, internet used or internet based. So with your case, with the social media platforms that you will update, one, I think there's something on social media or marketing platforms, yep, that moreover also on the design of your website and so forth, you'll have to consider in what methods would be preferred to collect data on such things. Is that okay, Musharraf?
Yes, sir.
If I would explain a tiny bit further on this, I might end up giving you the entire answer.
No,
So
I get it.
you get it? Okay,
Yes.
so I'll stop here before I actually reveal the answer to you. Okay, so it's just about you using some form of data collection techniques or data gathering techniques, and how did you attain the data to create a website? All right.
So I was confused if we actually have to find the data, but it's just we have to find the method we will be using to find the collect the data.
See, in this case, you don't generally like, it's a situation whereby you are sort of pretending to create a website, but you're not actually creating a website, eh? So you'll have to think of such methods. Generally, if it was by my will, I would have asked you to create an entire website. But what I do know that about, I could have asked you to create a website, but I do realize this, that some of you out of the class, you do not have website development skills. So that will make your work a bit difficult. Okay. For example, those of them who have done CIN603, I know you can create good trendy websites on this. You can also get something going. Okay. But remember, at the very beginning of the semester, I did tell you, this you can use this later onwards when you're doing CIN707 IT project. I think Musharat and Monish, you'll also do CIN707. So for next year semester 1. Okay, so you can use an example as such and create a website. For our CSI students, you will, I think Mr. Bimal Kumar will be taking a unit. I don't think he will approve you to do a website as such, because it will be quite too simple for CSI students. For education students, I think he'll accept working on this. So Monish and Musharat, I think this would enact as a good example, and you can work on this because you already have the information on you. Okay, but please do mention it if you're doing the very same project for 707. You do have to declare to Mr. Bimal Kumar that you had done the modeling part in CIN603. Okay. Okay. Yeah. Any other questions? Thank you, Musharat, for asking the questions. I think I also had questions from Semi last week, from Junior as well. Thank you for your questions and queries. Those of you who have further questions, please do let me know. Now, the payback analysis, okay, and the TCO and the payback analysis will start exercises on them from next week onwards. Okay, so if you're thinking how would you go around doing this, from next week's class. Okay, from next week class we'll start working on TCO and payback analysis, and within after one class you should be able to do that. Now, if you what I would suggest for you to do is leave these two portions so far, continue with the rest. Once we are done with TCO and payback analysis, you can go and fill in those values. Risk management, again, it requires research work. So your data collection, you can also mention how did you get data about risk identification and analysis. Logical design or logical model of the system, that means you creating the entire system in a paper format. Okay, generally this is what you're doing. You're creating a design on a paper format at the moment. And when you actually convert it into an actual website, that's the physical layout, okay, or the physical model. All right, any questions, any queries? No? Last call, any further questions or queries? If not, thank you very much for joining in and putting in. Yes, someone? Semi?
The appendix part, what goes there?
Appendix part, okay. Now in the appendix part, just in case if you mention that you have used a questionnaire, or in the appendix part, now do notice this, when you're doing a requirements modeling or the discussion on, where's this, hold on, give me a second. Yeah, payback analysis, okay, there's no requirements mode here, okay. Now for your data collection, if you're using any form of questionnaire, if you're saying that you're using questionnaire, okay, so you have to put there in your appendix. If you're using a interview kind of questions, so what questions, it needs to go in your appendix as well, okay. Just like generally when you do project, when you do normal projects, you have references and then appendix. Appendix generally means the all those documents which are not so important to the project, but they contribute to the project in one way or the other. You can always put them in the appendix section. So questionnaire, interview questions, okay. If you are doing an observation, or if you say you're using you're doing some form of observation, observing a website, in this case, what are the things that you're looking at? What is your checklist? Something as such. Okay, people. All right, Semi.
Thank you.
All right. So that's where we'll conclude the class for today. So thank you so much. Thank you for putting in your time and efforts. So I'll see you all on Thursday. Till then, take care, stay safe. Good night, everyone.